Section 4. You will hear a talk on the topic of driverless cars. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Hello everyone. Today's talk is about motor vehicle technology of the future, and in particular about driverless cars. So first, what is a driverless car? This is not a simple question, and the British automotive industry has set 5 levels of driver control on the route to truly autonomous vehicles. Level 0 or driver-only cars are what most of us are operating right now. By that I mean we control the car by operating the pedals and the steering. And if we lose concentration or fall asleep, we're in big trouble. However, our current Level 0 cars already contain sophisticated megacomputers. Did you know? There are over 70 small pieces of software in your car. They control the accelerator, the brakes, and lots more. Yes, you have to press the pedals, but after that the software takes over to actually operate the vehicle. Okay, so now Level 1 or assisted cars are already on the market. So what's different about these cars? They tend to have computer-controlled assistance for parallel parking or electronic braking systems. Some companies are also making Level 2 or partially automated cars. They have functions like adaptive cruise control and lane keeping. They can change their speed to match the car in front of them, so they can operate in heavy traffic. However, drivers still need to monitor carefully and be ready to take over if necessary. Now, note that higher levels are not yet available for commercial sale, but Level 3 or conditional automation vehicles will in theory be able to perform highway driving without the need for input from you, the driver. Well, not totally. They might need to ask the driver to take over in difficult situations, giving sufficient notice so that he or she is ready to resume control. So you can't go to sleep. So, what's the next step in this gradual process of developing automated vehicles? Yes, Level 4, or high automation vehicles. These cars may not have pedals or a steering wheel at all. Can you imagine that? They will be restricted to city environments, but in other ways are not so different from Level 5 cars, which will be fully automated in all situations. In this science fiction future, the driver may get into a vehicle, program it, and then sip coffee, sleep, or check the internet while the car propels him safely to his destination. Well, of course, there's intense competition among the automotive industry to be the first to produce and test a workably robotically controlled car. But these cars are nowhere near ready for open road driving. They can only operate on roads that have been extensively computer mapped, and they're very inflexible at dealing with anything unexpected, like new stop signs, for example. Let's see. Other technological issues for some models include problems with operating in some weather conditions, such as rain and snow. However, many insiders agree that these problems will eventually be solved, and that the biggest hurdle is getting the driving public to accept the idea. UK and US surveys in 2012 showed that somewhere between 37 to 49% of people would be comfortable owning one of these cars. However, at this time, only 22% of Germans were positive and 24% were hostile about the idea. A more recent international survey in 2015 indicated that 33% would like to own an autonomous vehicle, but most respondents still wanted to be in control of their car. Right, so another issue for the consumer is cost, though this could be offset to some extent because of lower insurance premiums. People may be nervous about autonomous cars, but, the facts speak for themselves. It's estimated that 90% of all car crashes are caused by drivers making mistakes. In 2014, in the USA alone, nearly 33,000 people died in cars. Driverless cars could hugely reduce that number. Some people estimate a 99% reduction in car accidents, but that would require 100% of cars to be robot-controlled. So what about the transition period? After all, whenever it begins, this change can't happen overnight. For many years, both human and computer-controlled vehicles will share our roads. Motorway driving is relatively predictable, but as we know, most cars are driven in complex situations in crowded cities. Even human drivers struggle to make split-second decisions in these situations. How can a driverless car be programmed to deal with crazy driving? But what's the biggest dilemma? It's an ethical one. How can we program a driverless car to make a choice in cases where an accident is inevitable? Should the car be programmed to choose the lowest number of injuries, or to protect its driver first? This issue is not trivial, and it could cause a big delay in the introduction of the new technology. Nevertheless, this change will surely come. The potential advantages are just too great. As well as slashing the road toll, the cars will potentially minimize road congestion, because robot cars will be able to travel much faster and closer together than we do on our current road networks. Eventually, this will reduce driving time and thus increase our productivity. Fuel costs will fall with more efficient consumption patterns, but I suspect driving won't be as much fun.
That is the end of section 4. You now have half a minute to check your answers. That is the end of the listening test.